Okay, so we've now talked about how to find slope given 2 points or given a graph, and we've talked about how to find y-intercept given a graph. Now we're going to actually graph a line, and you're going to be given the equation. The equation is going to be in the form of y equals mx plus b, okay? And this is kind of the universal formula type equation that is given to help represent a line graphed on a coordinate plane. Any equation that is written in this form will be linear, meaning it's going to make a straight line. May not go through the origin, but it will make a straight line. Please note that if your y is not isolated, you're going to have to isolate it. Right now that's not a big deal, but in the future it will be, so just kind of make note of that. So the first thing to do is to graph the equation. The first thing to do when graphing the equation is to plot the y-intercept. Okay, this is going to be the constant that's added or subtracted with x. So pretty much what that means is b is going to represent your y-intercept. Okay, now you've got to make sure that you pay attention to the sign of the number. Because it says plus b, if it says plus b, it's positive. If it says minus b, it's negative. So it's really, really, really important to note that if there is a subtraction sign, it's going to be a negative number. Now, when you plot the second point, you use slope, you have to start at the y-intercept, okay? So in theory, m is going to represent the slope. And use the numerator to determine how far up or down. Up is positive, down is negative. And then use the denominator to determine how far right. Then please use a straight line. Please, we don't want any wonky lines. And make sure that it goes across the whole graph, intersecting both points, and that the ends of the line should have arrows to indicate the line's going to go on forever and ever and ever and never end. Okay, we're going to do some examples. Please bear with me because I can't really use a straight line on here, so just kind of bear with me as we get through this. All right, so for the first one, okay, we are asked y equals x plus 4. The thing to note is that that is going to be your y-intercept, and that the invisible number right there is going to be your slope. Okay, so the y-intercept is 4. So we're going to go up to 4, and we're going to put a little dot. Now, our slope is, there's not a number there. What we have to know is there's an invisible 1 right there. And in our heads, we know that any number over itself, any number by itself, technically has a denominator of 1. So the slope of that number is like saying 1 over 1. So that means you want to go up 1 and you want to go right 1. Now we make sure that we go through the points and extend a line with arrows on either end, going through both of them. You're going to be using your straight edge so that yours looks a little bit straighter than mine. And ta-da! That's how we graph the line of y equals x plus 4. Remembering that the number after the x with the plus or minus is going to be our y-intercept. We knew it was going to be positive because there's a plus sign in front of it. And that the number, the coefficient with x, is going to represent our slope. We knew that there was no number there, so that had to be an invisible 1. And in order to make it a fraction for rise over run, need a fraction, we put 1 as the denominator. Taking a look at the second one. Y equals 2/3 x minus 1. We know that minus 1 is going to represent the y-intercept. So we come and we put a dot where y is negative 1. Now our slope is 2/3. That means we're going to go up 2 over 3. So we go up 1, 2 over 3. 1, 2, 3. Now we connect our line in both directions, making sure that we have arrows on it so that it goes off in equal directions. little better. Okay, hopefully you're drawing yours left to right just using a straight edge. For me, not quite as easy because I don't have a straight edge. And there's our graph for the line, y equals 2/3 x minus 1. Going on to the third one, y equals negative 3/4 x plus 5. We know that 5 represents the y-intercept. So we're going to put a dot at positive 5. We know that it's positive because of the plus sign in front of it. And we know that negative 3/4 is going to be our slope because it's a coefficient with x. The fact that it's negative tells us we need to go down and then right. So we go down 1, 2, 3. Then we go right 4. 1, 2, 3, 4. There's our slope. We extend the line, making sure to go through both points using a straight edge, and we put arrows on the ends to indicate that it's going to go on forever and ever and ever. Now, looking at these ones, kind of take note that the first one, x, the slope, was positive. Look at the line. When you think back to when we first learned slope, the line had to move in that direction, going upwards, slanting upwards, going left to right, for it to be positive. When we come this way to the second one, again, slope's positive, we have to slant upwards. Coming here, negative 3/4 is going to tell us, hey, that needs to slope downwards because going left to right, it's negative. Now we come to y equals x. For y equals x, we first have to calculate what is our y-intercept. All right, now in looking at the graph, we should note that, hey, the y-intercept, there's nothing listed there. So that needs to be what tells us that the y-intercept is going to be 0 because there isn't anything written there. For the slope, we know that that's the number before x. And based on the first one, we learned that that's going to be 1/1. So for our slope, that tells us to go up 1/1, and we end up there. Now we're going to connect the line, extending in both directions. We know that the line should slant upwards because our slope is positive. So to slant the line upwards, we extend it in both directions using a straight edge, and hopefully yours is going to be straighter than mine. Okay, please don't freehand it the way I did. And we have ended up with y equals x. There is our graph for that one. For horizontal lines and vertical lines, those are going to have slightly different lines. There's going to have graphs, slightly different equations for those. When it comes to doing vertical and horizontal lines, those graphs are going to look a little bit different. Okay? For any horizontal line, they could be in any direction, top or bottom, in reference to the x-axis. Those are going to be simply y equals a number. Whatever that number is, that's going to be a horizontal line because that's going to be what tells us that we have a slope of 0 and that our y-intercept is where the line crosses, plain and simple. For a vertical line, that's going to be the one that the slope is undefined. Okay, so let's pretend that we're doing, it could be left or right of the y-axis. Okay, and in these cases, because our slope is undefined, because the slope is undefined, when we go to write our equation, it doesn't cross the y-axis. I mean, take a look at it. The line at no point crosses the y-axis. Even if you were to have a line on the y-axis, it doesn't just have one point. It has every point on the y-axis. So our equation is going to be simply x equals the number. And so in the y-axis, that number represents where the line crosses the y-axis. This number is going to be where the line crosses the x-axis. So sorry those last two are kind of small and a little bit sloppy, but that pretty much sums up for you how to graph a line given the equation. It also shows the relationship between calculating slope and y-intercept, how it relates back to the graph.